Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. Today we're dealing with a very important chapter. This is the fourth chapter found in the grade 11 syllabus for physics in CBSE and previous year questions. And the name of this chapter is the laws of motion. So this portion talks about various aspects such as friction, Newton's three laws of motion, an analysis of the three equations of motion, and situations such as vertical motion, etc. So let's look at the questions that we'll be looking at today. So today's questions are very important and we urge you to watch the entire video. So this is our first question. In the given figure, the position time graph of a particle of mass 0.1 kg is shown. Find the impulse at t equals 2 seconds. So we have an xt graph, so this shows the velocity of a particular particle of mass 0.1 kg. So in order to solve this question, we need to have a good idea of what is impulse. Now, most of us will write impulse as just Ft, force into time. While that is true, it is not applicable for this case. Now, over here, what we're going to do is we're going to take impulse, which we can write as F times t, as change in momentum. So, impulse can be defined as the change in momentum. Whereas force we could define as the rate of change of momentum. Impulse is defined as the change in momentum. That's why impulse is often written as F dot t. So delta p will give you the value of impulse. Delta p is p initial minus p final. Now that means you'll have to take mu minus mv, which is equal to the following values. So over here, the velocity at the initial position is, increasing. So it goes up with a velocity of 2 meters per second. So the mass here is 0.1 times 2 minus mv. At this stage it is 0, so m times 0. So we don't need to write the value of m, that is 0.1, because anything multiplied by 0 makes it a 0 anyway. So the impulse is 0.2 minus 0, so the impulse is equal to 0.2, and the unit is in terms of momentum, kilogram meters per second. So 0.2 kilogram meters per second is the correct answer, so option A is the correct option. Now let's look at this question. A person is standing in an elevator. In which situation he finds his weight less? This question, asked in 2005, has always been an important question because this gives you the basic idea of how we should calculate the weight of a person during his motion in an elevator. So the basic idea is that in an elevator, the acceleration of the elevator changes the normal reaction of a person inside the elevator. So the normal reaction is dependent on the upward or downward acceleration of the lift. And since in a weighing machine we use normal reaction to measure the weight of a person, so therefore in a lift the problem is that the weight of the person changes as the acceleration varies. So over here we need to find the value of n less than mg. So when normal reaction is less than mg, so technically what this means is that normal will be equivalent to the weight of the object or person minus an upward force, because this is a non-inertial frame of reference, so we need to add a pseudo-force. So we will take the pseudo-force from the left hand side to the right hand side. So N equals mg minus ma, so m times g minus a. So at n is equal to m times g minus a, the normal reaction will be less than the weight of the person, so therefore he finds his weight as lesser than usual. So for this to happen, that is n equals m times g minus a, you need to consider the acceleration of lift in the downward direction. So why downward? Because the normal reaction, which is numerically equal to mg, is acting in the upward direction. So therefore, if the acceleration goes down, then the normal reaction becomes less. So that is why m times g minus a is the value of normal reaction in the case where you have downward direction of acceleration. So therefore, option B, when the elevator moves downward with constant acceleration, is the correct option in this case. If you look at option A, in option A, it is moving upward. So if you move upward, then n will be equal to m times g plus a. So that means the normal reaction will be greater than the weight. So that means the person would find himself weighing more on the machine. So option A is incorrect. In options C and D, whether the direction is upward or downward, the value of acceleration is 0. So when the value of acceleration is 0, then the normal reaction will still be equal to the weight of the person. So options C and D are incorrect. Therefore, the right answer here is option B. When the elevator moves downward with constant acceleration, a person standing in an elevator finds his weight to be lesser than his usual weight. This is the next question. A person used a force F shown in a figure to move a load with a constant velocity on the given surface. Identify the correct surface profile. So these images are for surface profiles. The figure is like this. So this is a graph, and in this graph, this is the x-axis, and 0, the origin lies on the intersection of the x and y-axis. And initially he has a positive force F, and he applies it, in a constant term. Constantly he is applying a positive force, and then suddenly the force becomes negative. And then at a particular point it stops, and it is going across a length, say L, since it's a force displacement graph. So the distance between 0 and this point, say P, is equal to L. So now we need to find out which of these surface profiles matches the graph given. So this is the graph which is given in the question. We forgot to embed it, but this is the correct one. So if you look at all of these options, you will notice that some of these surface profiles will not give us the correct graph. Only one of these will give us the correct graph. Now if you look at each of them, let's start with option D here. So in option D, this object, so a load, for example, is moving across a circular path. So this is moving in a semicircle and meeting at the other side. So what happens here is that as the object is moving along, the direction of the velocity changes. So the direction of the velocity changes, so that means the condition of constant velocity will be absent in option D. So therefore, option D cannot be the correct surface profile. If you look at option C, you notice that there is an initial slope So if you have an initial slope, then that means the force F is used to act against mg sine theta. And then it reaches the top. Now when it reaches the top, it goes at a constant velocity. So the surface here is flat, and for surfaces with no friction, a constant velocity does not require a force always. So the negative graph is not possible in option C. In option B, the positive part of this graph is not possible because because the object is moving in constant velocity in a flat surface, which again is incorrect. Now, but as it's moving down, mg is acting on the object and trying to move it down, so the person has to apply another force F in the opposite direction so as to keep the velocity constant. So over here the condition is that the velocity has to be constant. So therefore option B and option C are incorrect. So therefore the right answer here is option A. So if you look at option A, first the force F is acting against mg sine theta as it moves up. So this is a particular direction, and then at the top it momentarily rests and then it goes down, and in order to avoid avoid acceleration, you have to add a force F in order to make the object move down with constant velocity. So and that force, which is like this, happens to be the exact opposite, so it's in a negative direction. So therefore option A correctly represents the graph in this drawing, and it is the correct surface profile for this graph. Option A is the correct option. Now, next question. A man of mass 60 kg records his weight on a weighing machine placed inside a lift. The ratio of weight of the man recorded when lift is ascending up with a uniform speed of 2 meters per second to when it's descending down with a uniform speed of 4 meters per second will be. So if you look at the question by itself, you might think, yeah, we'll have to do a lot of calculations. You have to find the normal reaction for the two cases. But that is not so here. Because if you read this question in between the lines, you notice that you're not given acceleration. You're given uniform speed on both cases. Even when the lift is ascending, it's going at a uniform speed of 2 meters per second. And if it's descending down, that is also with a uniform speed of 4 meters per second. So uniform speed of the lift implies that the acceleration is equal to 0. So when the acceleration of the lift is equal to 0, there is no change in the normal reaction. So the weight of the person going up, let's say that is 60 g, when it's moving up, will be equal to 60 g when he's moving down. So therefore, weight 1 divided by weight 2, that is 60 g divided by 60 g, is equal to 1. So the ratio of both of these weights is equal to option B, 1. The reason why is that here, because it's uniform speed, there is no acceleration. Without acceleration, there is no change in the normal reaction, and a weighing machine always measures the normal reaction and not your exact weight. So therefore, when you're moving in a lift with uniform velocity, the normal reaction in these cases is equal to mg. And since g is not given and m is given as 60, we just took it as 60g. And W1 by W2 will be equal to 1 because both these values are the same, so they cancel each other out. The ratio is equal to option B, that is 1. Let's look at this interesting question. Now, in this question, a smooth block is released at rests on a 45-degree incline and then slides a distance d. The time taken to slide is n times as much on rough incline than on a smooth incline. You need to find the coefficient of friction in this scenario. So first of all, you need to compare both of these motions. So a smooth block is going down a smooth slide, and then it's moving down a rough incline. So over here, you are given that the distance here is d, and the angle theta is 45 degrees. These are the information that's given in the question. So let's take this distance d as the displacement s and g as the acceleration. So therefore, what you can see is that d or s can be written as ut plus half at squared. This is the second law, the second equation of motion. So when we consider u as equal to 0, a as equal to g, then you have s is equal to half gt squared. So s is equal to half gt squared. Now let's do both of these cases parallel. So let's write smooth on the left hand side and rough on the right hand side. So if you notice, in a smooth incline, we have sine 45 is equal to opposite divided by adjacent. So sine theta is d divided by the vertical, which we can consider as g. So therefore, g sine theta will be the acceleration of the object as it slides down the smooth plane, because there is no force to oppose it. So therefore, there is only acceleration along gravity, and that too with respect to theta. So therefore, in a smooth plane, the value of g is equal to g sine theta. So that means you can write the displacement, that is d, as equal to half times g sine theta times t1 squared. Let's take t1 as the time that the block takes to move down a smooth slide. Now let's take t1 square as 2d divided by g sine theta. So therefore, t1 is equal to 2d divided by g sine theta, and all of that is under a big root. So this is the value of t1. Next, if we look at the rough plane, in a rough plane, what happens is that because of friction between the block and the plane, the slide, there is an opposing force to the acceleration, to the force that is exerted by gravity. So there is an opposing acceleration in this case. So on taking the normal and mg, you will get a value of mg mu times mg cos theta to be equal to the retarding force. So mu g cos theta is the acceleration which is opposing the acceleration due to gravity. So therefore, the total acceleration in the rough plane, g, is equal to g sine theta minus mu g cos theta. So therefore, you can write the displacement here, that is d, as equal to half times g sine theta minus mu g cos theta into t2 the whole square. Now notice that I'm still using the same variable d because both the planes are similar in every other respect except for the fact that one of its surfaces is smooth and the other one has a rough surface. So over here you can write t2 as under root of 2d divided by g sine theta minus mu g cos theta So that is the value of t2. So if you look at the question, in the question it says the time taken to slide is m times as much to slide on rough incline than on a smooth incline. What that means is that the value of t2 is equal to n times the value of t1. So therefore under root of 2d divided by g, and then you take the bracket out, sine theta minus mu cos theta, the whole root, equals n times under root of 2d divided by g sine theta. So over here you can cancel out 2d even though it's inside the root, and you can cancel out the g, which is common. So that means what you have is 1 by sine theta minus mu cos theta, the whole root, is equal to n times under root of 1 by sine theta. Now in this scenario the value of theta is the same. It is 45 degrees. That means the value of sine theta, which is equal to the value of cos theta, is 1 by root 2. So putting that on the equation, you'll get under root of 1 by root 2 minus mu times of 1 by root 2, all of that is under root, equals n times 1 out of 1 by root 2. So in both the denominators 1 by root 2 is common, so you're cancelling that. So therefore the value of n is equal to under root of 1 by 1 minus mu. And let's write this mu as mu k for the plane. So let's square both sides. So n squared equals 1 by 1 minus mu k. So what you get is 1 minus mu k is equal to 1 by n squared. Or you can write mu k is equal to 1 minus 1 by n squared. So 1 minus 1 by n squared, if you look at our question, is the same as option B. So therefore option B is the correct option. Now let's look at this question. A parachutist, after bailing out, falls 50 meters without friction. When the parachute opens, it decelerates at 2 meters per second square. He reaches the ground with a speed of 3 meters per second. The question is, at what height did he bail out? So over here we have two scenarios in common. Two scenarios in this problem. The first scenario is after bailing out of the plane, a parachutist goes down 50 meters, and we're supposing that there is no friction at this stage. And then he opens the parachute. When the parachute opens, there is a significant amount of friction, and that friction ensures that the parachutist is decelerating at 2 meters per second square. And the final velocity when he reaches the ground is given, the final speed when he reaches the ground is given as 3 meters per second. You need to find out the total height of the jump. So over here, for the first part, that is falling 50 meters without friction, we can use the third equation of motion. So technically v squared minus u squared is equal to 2as. And when u equals 0, a equals g, s equals h, you'll get v squared equals 2gh. That means v is equal to under root of 2gh. So for first part, let's consider g as equal to 9.8 meters per second square, and let's consider h as 50 meters because it's given in the question. So therefore you have the velocity as equal to under root of 2 times 9.8 times 50. So 2 times 50 is 100. 100 times 9.8 is 980. So the velocity is under root of 980. Now, when you divide 980 by 5, so 5 goes into 9 one time. So that is 5 gives you 4, 48. So you have 9 times, that is 45, 3, 0, so that's 6 times. So 980 is 196 into 5, so you can write that 196 into 5, the whole root. So therefore, the velocity before opening parachute is equal to 14 root 5 meters per second, because under root of 196 is 14, because 14 square is 196. So the velocity that he reaches before opening the parachute is equal to 14 root 5 meters per second. Now, why did we calculate this velocity? Because from here onwards, we're looking at the second part. Now, in the second part, friction reduces the speed of the parachute or the parachutist. So let's consider that the parachutist drops a height h, and over here you can still use the third equation. So v square minus u square equals, say, 2gh. So you can write h as v square minus u square divided by 2g. So in this scenario, the second part, you have v as equal to 3 meters per second. U is the velocity that we just found out, that is 14 root 5 meters per second. And g is, again, now g, or let's write a, the acceleration here. So over here, you have a constant deceleration of 2 meters per second. So therefore, it will be 2 in this scenario. So the value of h is equal to 3 whole square minus 14 root 5. The whole square is 980 divided by 2 times 2. So therefore 9 minus 980 divided by 4. If you take 980 minus 9, you get 971. Divide that by 4. So 4 goes into 9 2 times. That's 8. 4 goes into 17 4 times. That is 16. So there is a 1. And then you have 4 going into 11 2 times, minus 8, which is 3.0. And then you write 7. That is 28, gives you 2. And then if you write 5, because there's a 20, minus 20 is equal to 0. So the value of h that you get is 242.75, which you can approximate using significant figures to a value that is 243 meters. So for the first part, the height is given as 50 meters. And for the second part, we found out the value of height that is equal to 243 meters. And since we're asked to calculate the height of the jump, the total height, h net, let's suppose, is equal to 243 plus 50, which is equal to 293 meters. So therefore, if you look at our options, you can see that option D gives you the correct answer. Now, the trick here to this question is to identify the two types of motion that is occurring, the one that has free fall and the one that has deceleration due to the parachute, and then solving accordingly. So using the free fall, you have to find the velocity at which the person tries to open the parachute, and then from there on you need to find the height of descent for that particular case. So once you have both the heights, you can just do simple addition to get a total value of 293 meters. Now this is the final question for this episode. Over here you have an 80 kilogram person parachuting and experiencing a downward acceleration of 2.8 meters per second square. The mass of this parachute is 5 kilograms. You need to find out the upward force on the open parachute. And we can take G as 9.8 meters per second square. Now, G is 9.8 meters per second square, and it's given that the downward acceleration is equal to 2 meters per second. 2.8 meters per second. My apologies. So, the question is to find the upward force on the open parachute. So the open parachute effectively reduces the value of G. So the total acceleration in this case has to be the difference between 9.8 and 2.8, which is equal to 7 meters per second square. And if you look at the mass in this scenario, for the person, the mass is 80 kilograms, and for the parachute, the mass is 5 kilograms, because parachutes are quite heavy because you need to have a wide area to get that downdraft. So to get that updraft. So a total mass of 85 kilograms is accelerating in the air. So you have total mass 85 kilograms and total acceleration as 7 meters per second square. So now you just need to find F net. That's what we need to find here, the upward force on the open parachute. That is F net, which is equal to mass times the acceleration net, so the acceleration on the open parachute. So therefore you will have the mass is 85 and A net is 7, so 85 times 7, 5 times 7 is 35, 8 times 7 is 56, 56 plus 3 is 59, so therefore 595 newtons is the net force which is acting upward on the parachute, on the open parachute. So therefore, if you look at our options, you can see that option A is the correct option. Here the perspective is very important. The perspective is on the open parachute, which is why we're taking the difference between both the values of acceleration. Now that concludes this episode of NEET preparation. We hope you found this episode interesting. We have more videos on laws of motion which contain more important questions about it. So you can always hit the link in the description down below to access that. To get more of our useful and interesting content, such as learner words, mind maps, etc., you can always subscribe to our channel, which is Brain Blitz Audio. So until the next webisode, take care, stay safe, bye-bye for now.